Hi, I'm Joe Benedyk. I'm the editor of Light Metal Age and also a research professor at IIT TPTC, the Thermal Technology Processing Center. And I would like to tell you a little bit about the paper that I'm going to present at ET12. This paper is a compilation of a lot of historical articles from Light Metal Age magazine, which started in 1943, and we've collected over 1,000 news items and articles and news items relating to aluminum extrusion, and I'm trying to put that into perspective. How? I've decided to consider the extrusion process as one long chain of different segments, starting with, of course, extrusion design, die design, alloy selection, and going on from there. Now, among the alloy options available, 6063 seems to be the lead horse, and 6063 for years has been considered to be the mechanism for hardening 6063 over the years has been considered to be the formation of magnesium silicide. In the last 10 years, a significant change has occurred due to the fact that metallurgists have been able to actually follow the nano stages of precipitation through very specialized microscopes. These microscopes have basically come up with a startling conclusion. At the maximum peak hardness, we have 1 atom of magnesium to 1 atom of silicon. All these years, we've been putting in more magnesium than we need. Well, magnesium tends to raise the force of extrusion and also cuts down on productivity because surface defects are more prevalent. The more magnesium in the alloy at higher speeds. So many companies, aluminum companies, have come up with new ideas for new types of 6063 alloys that are basically lower in magnesium and lead to a lot of advantages. Once the billet is cast, there's a lot of research that has gone into homogenization and into billet handling for optimized extrusion. How do we do this? Well, everybody in the industry seeks the magic bullet of isothermal extrusion. How to extrude the front of the billet, the back of the billet, so that everything comes out at the same temperature. After the billet has been properly processed, we now get to the equipment. And among the big changes that we've seen are in the last few years are larger and larger presses. Another aspect of the business, and I've talked to people from different companies, there is a big refurbishment movement going on in the United States where the older presses are basically put into shape to meet modern productivity targets. And the difference between good extruder and average extruder are significant and can make the difference between success or failure in the business. Now, once the product is made, among the other technologies that I will be discussing are fabrication, or being able to bend extrusions. Among these techniques are Institute of Metal Forming from University of Düsseldorf, Technical University of Düsseldorf. They've developed a process for bending extrusions to very precise tolerances at the press. Let's close this out with the aging process. The aging process in many plants is a bottleneck. We're talking as many as 8 to 10 hours of aging. With 7,000 series alloys, this could be as long as 2 days. Now, a lot of research has gone into shortening this process. Among the techniques are a double aging process, which was actually developed at Illinois Institute of Technology where I was working, and where we were able to cut down the aging time for 7075 T6 from 24 hours to 2 hours by selective double aging, a preliminary aging step to grow precipitate particle seeds or seedlings, and then a second aging step to accelerate their growth without dissolving them. It's tricky, but it's doable, and we will be covering more on this in the future in light metal age. Thank you.